Swayam Prabha. Digital India. Educated India.
Hello everyone, welcome to this lecture. We already have discussed about the demand function and how we derive individual demand from the utility, and we also have discussed about optimization conditions from the utility and the budget constraints. So we also have discussed about substitution effects and income effects and price effects, because we already discussed that how changes in prices of any commodity, it has power or impact on income effect and also the substitution effect. So now today let us see how we can derive market demand from individual demand. So by definition, the quantity of a good that all consumers in a market will buy at its price, we have already discussed about the individual demand curve, and if assume that n number of consumers are there in the market, then summation of all the individual demand curve will be regarded as market demand curve. In other words, horizontal summation of all the individual demand curve will be considered as market demand curve. So now let us see how it looks like say here for individual A and here individual B, and then on the horizontal axis, as we know, is the quantity of X, and here also quantity of X. We are talking about commodity X, and here the price of X, and here price X for person B. Suppose this is the demand curve for A and for commodity X, and this is demand curve for individual B and for commodity X. Suppose here at P X star price, individual A is consuming X1 amount of X1, and at the same price level individual B is consuming X2 amount of commodity X at P star X of the price. Then market demand curve will be horizontal summation of d I X, and here I equals to n to 2. We have considered only A and B, only two individuals, and it will be flatter, and here total quantity will be X1 plus X2 at Px star of the price. So this is say market price, and this is total demand function, like market demand curve of commodity X. So this is how we can derive market demand curve from the individual demand curve. And if individual preferences changes, and then one individual's quantity will also be changed, but then summation of all the individuals will be demanded in the market, and accordingly it will be supplied by the producers. So before moving to supply curve of the market, let us first try to understand the production and the producers behavior. We will not discuss at length about production functions and production behaviors and every details, but then we'll try to discuss couple of points that we require to discuss about the public policy and economics of public policy. So now let us couple of concepts already we know from our utility functions and also the demand functions. So now let us also understand how other factors or rather factors of production that are required for the producer to produce goods and services on which supply of that particular commodity will be supplied. So let us discuss. The first concept is fixed inputs. Couple of inputs in the production function will be fixed, and couple of inputs, for instance labor and capital, so these are variable inputs. So now in one of our previous lectures we already have shown you that how farms and households they are interrelated, and especially with regard to macro national income equations. So here again we can bring farms and households, like here farms, if we draw here, and here say households, and farms will demand for say land, labor and capital. In return, farm will pay to the household rent for land, wage for labor, and small I rate of interest for the capital. That farm will borrow money from the financial institutions, and that's how farms, financial institutions and households will be interrelated to each other, and government also play an important role. So we already discussed this relationship and then these networks in our previous one of the previous lectures. So here just to bring those concepts again, like how farms and households are interrelated. So here say labor and capital, these are variable inputs because it changes with time. So wage will be paid, so wage is the price of the labor, and rate of interest is the price of the capital. So rent, wage and rate of interest are factor of payments, as we already discussed. I'm reiterating that land, labor and capital, these are three broad factors of production. So how production function will look like? So say suppose production function we are referring as capital Y, which will be function of labor and capital, and we are keeping all other factors constant under ceteris paribus conditions. And here if I give equation 1, so equation 1 is the production function for the farm, where land and labor and capital are two variable inputs. So now what is total productivity? Total productivity is getting represented with Y. So Y is suppose say total productivity. So what is average productivity? So if we consider in this particular concept, like when we consider one variable proportion, either we can keep K constant or L constant. Suppose we are keeping in this production function in equation 1, like say K constant, then L is only variable, then what would be the average productivity? So average productivity will be like total productivity divided by total number of labor, then we get the average productivity. So what is the marginal productivity? Marginal productivity is nothing, the same marginal concept that we already discussed in our previous lectures, like change in total productivity due to 1 unit change in labor. Likewise, I mean, if labor is variable, if capital is variable, then total change in total productivity due to 1 unit change in capital. So this is how we get marginal productivity of labor, and here we get marginal productivity of capital. So as you already know from your introduction to microeconomics class or intermediate microeconomics class, so there this is how production, total productivity, marginal and we can derive average productivity and marginal productivity from the total productivity. So how one can draw? So this is what we need even in our discussion as we proceeds. So if this is like total productivity, like we represent with y, and here we are keeping only L variable, and then we draw this as like total productivity. So as we know that total productivity will increase, and here you will see 2 points of inflection, and here total productivity will reach at maximum, and then the point at which total productivity reaches maximum, say at L star amount of labor, so where marginal productivity will be 0. Here L, and here say marginal productivity, and this is how total productivity and marginal productivity, they are interrelated. So after this point say point capital E, after this point total productivity will start declining, right? And when marginal productivity of that additional amount of labor will be 0, like beyond L star. So this is what how when we consider one variable and say that is labor, and how this production function and total productivity and marginal productivity and average productivity, how they are related. So now let us move further. When there are two variables where labor and capital both are variable in the production function, and then we can again draw as this capital Y is a firm's total production function, which is a function of labor and capital, and law of diminishing rule will be followed, and here again rate of substitutions. So it's basically here if we consider two variables, and that are L and K, and we are choosing between L and K with the same concept that the way we discussed in case of utility, with the help of indifference curve, like how X and Y will be interrelated with the help of marginal rate of substitution. The same logic, following the same logic, we'll also discuss about how diminishing law and also how marginal rate of substitutions in this production function, marginal rate of technical substitutions are connected when we choose between L or K. Suppose we have two, like if we illustrate with the help of graphical representations, like say on the horizontal axis we consider labor, and on the vertical axis we consider capital, and here L and K both are variable, and then if we draw following the same law of diminishing, and here say here the production function like Y is a function of L and K, and in this say here point A and point B. So if I move from A to B, so at point A, suppose firm is using OL1 amount of labor and OK1 amount of capital to get this much of production, and if firm chooses to move from A to B, then capital will be reduced from OK1 to OK2 amount of capital, but then labor will be increased by L1 and L2, means here delta L and here delta K. So but producer is on the same isoquant curve. So here in case of utility we called indifference curve, we used indifference curve to explain marginal rate of substitutions, and then movement between A to B and B to A, we use that with the help of indifference curve. In case of production function, we are actually using isoquant curve, as you know. So isoquant curve shows all the combination between labor and capital for the farm to produce, and that's how the production is taking place. So it's basically producer will be satisfied or will be happy to either to be on A or B, because producer will be on the same isoquant curve. In case of B, producer will be using more labor based on the availability of labor, or we can say that in case of surplus labor, or if producer chooses to be on at point A, means producer has more capital as compared to labor, and therefore producer chooses to use more capital on A. So this movement between A to B, it is basically marginal, with the logic of marginal rate of technical substitutions. So the same point that we same logic, by the same logic we get like say here y equals to function of L and K, like say again say K is a constant, like total, using this much of labor and capital, using maximum level of resources, producer can have K amount of maximum K amount of output, and then any point on this production function on this isoquant curve, like say Q1 IQ1 curve, all the production will be same and constant. And then if we have the total derivative here, then marginal is like L dl plus df by delta K and dk, and since y equals to constant, like K, and then this is nothing because this is marginal productivity of labor dl and marginal productivity of capital dk equals to 0. Likewise, say dk by dl is basically minus mp L by mp K, nothing, it is marginal rate of technical substitution between L and K. It is basically substituting between L and K by the producer. So this movement between A to B is basically the substituting one over another, and in this case substituting L by K or K by L. And this is what is nothing, is like marginal rate of technical substitutions, and this is again this negative sign represents the downward or diminishing law of diminishing. So now let's move to equilibrium condition for the firm, like firm's optimization conditions. So we already know that what is production function, and production function here y equals to L and K, and then total cost is nothing, is basically again assume W is the price of per worker, means wage rate, and then L is the total number of employed in the firm. So WL is total amount of cost that is going towards labor hiring, plus small I is rate of interest of the total capital that are borrowed. So WL plus small ik is the total cost towards L and K, if we are considering only L and K, two variables in the as factors in the production function. TC is nothing, is basically the similar feature that we already know from our budget line, like constraint. So this is like production function again, one, and here equation 2 is cost function for producer, and isoquant is getting isoquant we are getting it from production function, and this total cost is getting represented by the ISO cost line. So following the same property or the same rules of the constant, like budget line, so total cost also have the similar property here. So say, let's see, this is linear function, this is ISO cost, like total cost function. So ISO cost line, and suppose L is labor is measured along with the horizontal axis and K along with the vertical axis, and then this is our isoquant curve, which is nothing, is basically production function, and here is the, say, at point E is the optimization point where producer will optimize and use, say, OL star amount of labor and OK star amount of capital will be optimally used to produce goods and services. So this is like MRTS, L and K, which is nothing is marginal productivity of labor by marginal productivity of capital, nothing by with the same logic. In case of consumer behavior, we saw that optimization conditions was fixed at a point where mu x by mu y, which was nothing, it was marginal rate of substitution, like MRS xy, was equals to mu x by mu y equals to px by py. It's like price ratio, like MRS equals to price ratio. Here with the same logic, marginal productivity of labor and by marginal productivity of capital is nothing is equals to marginal rate of technical substitution between L and K, which is equals to ratio between W and I. W is the price of labor and I is the price of capital. So here is the choice of the factors of production, like producer choose to have O K star amount of capital and O L star amount of labor to produce certain goods, because that is where production function and cost line are meeting or tangent to each other. So I'll stop here. We have discussed about briefly about the producer's behavior and how to choose between L and K in case of production function. So in our next class, we'll discuss about the cost behavior and then how supply curve we derive from cost and then from the production. So these are the three texts that again I'm referring, those who are following this lecture. So you are requested to study selected chapters from Stiglitz and Jonathan Gruber's and Pindick and Rubenfeld. So thank you very much for your attention, and I'll see you in my next lecture.